everybody for joining us this morning for our talk as part of Birmingham Tech Week. This is DataOps on Azure. We are recording the session and we do want you to ask as many questions as you would like using the Q&A functionality. There'll be time as we go along and a bit of a break in the middle as well. So without further ado, I will hand over to Simon, who's leading today's session.
Hi, thank you. Okay, so so this is a talk about DataOps with Azure, and it's going to be a journey through the different services that that Azure has to offer, how you can incorporate those into a DataOps culture, how they support a DataOps culture, and the different types of data and patterns that you can use with them. So I'll just start talk a little bit about BGSS. So we're a privately owned business and IT consultancy that's been around for 27 years. And one of the really great things about being privately owned is we're encouraged to embrace tools, processes, and cultures that really support doing the right thing for our customers. So a lot of the topics that we're going to be covering in today's session around DevOps, cloud native deployments, and data are examples of that, where we've been able to embrace those technologies and deliver great services to our clients. Here, this is me. So I'm a data architect at BGSS, and I've been here for like 3.5 years now. And through that time, I've worked predominantly on data platforms and also using the Apache and the Azure tech stacks. My social media links are at the bottom. Sometimes some posts around Azure and data for people to look at if they're interested. So we'll start now with DataOps, and really let's just start with what DataOps is. And if we start with DevOps, which a lot of people are really familiar with, Donovan Brown from Microsoft describes DevOps as the union of people, processes, and products to enable continuous delivery of value to end users, and that's really like the foundation for DataOps as well. There is a real focus of delivering that value to the end users, and also treating all of the analytics and data services which are being developed as code, and understanding that these are manufactured through a process. We need the experimentation at the beginning, but we also then need to move from experimentation into robust engineering practices and reproducibility throughout. So here we have a cycle through the different phases that we move through in projects, where we will often have like a business case or a hypothesis that we want to work on. We want to deploy services and aim to like find the insights that deliver value. From that definition, we obviously need to get access to data. We need to carry out experiments, and we need to see if it's viable. With DataOps, failing fast is a really good thing. If the data doesn't support the hypotheses that you want to find, then as soon as you know, then that's the right time to like kill the experiment and look at the next one. But once the experimentation shown that there is the business value, then it moves into the development and deployment of that. And this is where the robust software engineering principles and everything come in. And we pick up on things like automated testing that can improve the quality throughout the pipelines. We need to make sure that there's reproducibility. So a lot of data services which are developed will impact end users. They can make decisions for end users that can impact their lives. So having that reproducibility, so that you know exactly what data was built into a model, you know exactly how a model was built, or a pipeline, is key for that. And that moves into the orchestration phase. You've got the ability to track lineage of data. You're implementing security, privacy, and things like that as well. And then finally, we need to monitor everything that we're doing, so that we know if things are performing as they should. A lot of the work that goes on in data science in particular is to drive change. You want to alter people's behavior through providing services, and as that behavior starts to occur, the data will start to change. So we need to be able to detect when the data or the model are no longer performing as expected. And then that really repeats the cycle again. So if we move on, next, we can look at like data platforms that that can really support these ways of working. So we have it's all Azure icons here, but a lot of these concepts will apply equally to any cloud, any CICD tooling for pipelines, and any governance layers that you want to put around. But as today's Azure, we'll talk about some of the specific services here. And there's a case study later that goes into a lot more detail about how these are used to actually work in the real world. So right in the middle, there's the platform itself, and this is really showing a modern data warehousing pattern, where data is ingested from various different sources. It's moved into a store, and in this case, we'd be using something like an ELT pattern, where the data is landed into a data lake, and it can be read many times. And we use an ELT pattern for extracting, loading, and then transforming the data, as opposed to an ETL pattern, which is extracting, transforming, and then loading the data, because it allows users to like start with that data again from the data lake storage area, and look to see if they can identify different problems that they would like to solve later on. If that data was modeled immediately, then the only data you have is that model, which can be a bit restrictive. And once the data is stored, we need to look at how we orchestrate various different parts of processing and landing that data into a service that can be used for analytics. So here we're showing Databricks as an example of that, and also moving into a data warehouse. After that, we want to build a dimensional model, or maybe some data science models that we can serve to users, and then we have presentation. So this is actually showing analysis services representing a dimensional model and Power BI, allowing users to then consume that model and look for insights. So this would all be built using CICD pipelines, so that you have collaboration, building as a team. You've got version control, which is the start of that lineage, and you've got repeatable build pipelines with automation testing to prove quality. And then above the platform shown here, we've got all the different aspects of cloud governance around identity and authorization, secret management, the operational aspects, making sure that you can log, monitor, alert, and that you're compliant at all times. And then the performance around right sizing to make sure that you can cost optimize where necessary. So moving on to looking at the 5 pillars of cloud excellence, we want to make sure that everything that we're deploying is secure. Data is a massive risk. It has really high value, so we need to make sure that everything is done to protect that as possible. And so that it's locked down so that you know if anything's happened. There's often lots of regulatory compliance that goes around like the process to happen if a data breach occurs. So the first thing we want to do is prevent that from happening, but it's often seen as a when it happens rather than if it happens. So making sure that everything's in place to limit who can access what data, the separation between data sources is really key for security. Reliability is making sure that we can recover, so having failover regions and failover services, having replication of data. And then as we move through some of these, we've got like the performance efficiency, making sure that we can scale to meet the changing demands in needs for data, the changing demands in the size and volume of data, or the speed that the data arrives. Briefly mentioned cost optimization. The amount of data that enterprises deal with now is massive, and it's a cost to keep it. So what we want to do with cost optimization is look at opportunities to reduce that cost wherever possible. So using services where you only pay for the compute that you're using, so almost a pay per query model is good. And then the operational excellence brings all of that monitoring into to the business, so that you can see how your investment is performing over time. So what I'm going to do now is give a case study of where we've applied like the previous 3 slides to with an actual client. We've had a vision that was set by the CDO for Highways England of becoming a data-driven organisation that can support the strategic road network over the next 30 to 50 years. So the platform now won't be the same then. It's the start of that. It's getting the principles, the foundations in place, the understanding around data, treating data as a service that users can consume, that's provided by the business for the users. And then also seeing data as an asset that has value that can be nurtured and can increase in value over time. That's a lot around the vision. And we were working with the head of data architecture and engineering at Highways England to bring the concept of data as a service to life, to build a cloud native platform and to facilitate self-service access to data. And then along the way, we've had a lot of partnership with third parties to make that happen. So we're going to have a quick journey now through how we did it, the different parts of the platform. So this is a very tech focused how we did it. That's going to look at the different services that make up the platform, how we built that into various different processes for releasing, and the security and everything that went along with it. So if we start back in December. So this is December 2019, and that's when we first received access to a subscription in the Highways England Azure tenant. And at the end of December, we wanted to start deploying services. So we were taking a steel thread approach to building this platform. So with the steel thread approach, we identified a single data table that we could build a pipeline around that would really accelerate getting the platform deployed. And key for that was making sure we had the good principles to start with around like the security, performance, the ability to monitor everything. And we wanted to design this way from the beginning. In the preceding months before December, so October, November, December, we went through a number of activities with different stakeholders in Highways England to understand the problem domain, to look at how we could, what the user needs were around data, the different use cases that we would be implementing with the platform that would help inform the services we needed to select. We also worked quite extensively with the enterprise architecture team and made sure that what we were building fitted in with their vision for the use of cloud throughout Highways England, and obviously with the InfoSec team as well, making sure that what we were building met their requirements and obligations for protecting that data. So towards the end of December, we deployed what we see on the screen here. So we started off setting up the platform for success. So identity was all managed through the Azure AD, which is really brilliant from a service point of view, because the user lifecycle then is managed outside of a data platform. It's managed by central Highways England teams that onboard users, move users around teams that deal with third parties. So it takes a lot of that identity management out of the platform, and we're separating things into the right areas. We defined a lot of RBAC. So once the user's been authenticated by the Azure Active Directory, we can authorize them to access different areas. So whether that's access to the data warehouse, whether it's access to services, or if it's access to files in the data lake, all of that is something that the platform can define. So we've got that separation of authorization is centrally managed, whereas authorization, did I get that right? Authentication is centrally managed. Authorization is managed by the platform. We also made sure that there were sufficient policies in place to know that what was being deployed was a sound platform. If we move on to the actual platform design itself, we identified core services that would be needed by like many different users of the platform. So things like the data lake, the data warehouse, and also the data processing fell into that category. Whereas the data ingestion is something that would scale over time as more data sources were onboarded, and had different requirements around connectivity and secrets and things like that. So our first platform, the Steel Thread, I spoke about, was deployed into the platform at the end of December, around the holiday period. And then we also made sure that everything that we had in the platform was providing logging, so diagnostic logging and metrics to a centralized set of services that we could interrogate if we needed to find out what was going on. So moving on into January, this is where we got access to the CICD pipelines, the Azure DevOps service, and we could connect it to Azure. So we started building out the pipeline that took the modular templates we'd used previously, and then just wrapped them around through the build and release process. And this was really starting off how we would like manage different environments for dev, UAT, and production. And in here we had like the infrastructure templates that could be deployed. We had the different artifacts containing those, and we had a number of infrastructure tests that were really providing feedback for information security. They were really interested in certain key settings on services that we could wrap up with testing. We could get an early indication as to whether things were compliant for their needs. And we're talking things like encryption at rest, encryption in transit, making sure that PaaS services have firewalls, looking at the different SKUs of services that were being deployed as well, and the connectivity between networks as well. And the brilliant thing about tests is that they really document the platform that you're building as well. So here we have the CICD pipelines that we just spoke about, and we actually executed the pipeline once we had the CICD pipeline in place. We were able to ingest that single data source into the platform, and we now had like taking that data from its source location. We would then process it, we would ingest it, we would land that data into the data warehouse, and it was then queryable. It wasn't yet made available to users, but we had data in the platform, and that was actually quite a surprise for InfoSec, with it happening within a few weeks of speaking to them. And that was mainly because we were following like the DataOps delivery approaches, the way that we were using an agile methodology for running our project. We had CI/CD pipelines that could repeatedly deploy and execute the pipelines. We had all of the governance baked in. We now needed to start working with them again around a lot more around the access. So we had gone through all of the privacy and impact assessments for bringing data into the platform, and in the development environment, everything was anonymous, but it started raising the questions of who should have access, and we started to work with InfoSec a lot more around those aspects. So the process of data being brought into the platform. So alongside the infrastructure and the platform build and the data pipelines, we also had the service wrap. We had service designers, and we were applying design thinking to the builds for this platform. So a lot fed into there of how do we responsibly bring data into the platform and onboard those different data sources. So if we move on into February, we started to scale at this point, bringing more data sources into that first pipeline, but also bringing additional data pipelines into the platform as well. And the key for making this work was looking at having like a configurable way of specifying those like data landing zones, the data ingestion pipeline. So we defined a configuration file, and we used that to parameterize the different templates. So if we just move through, we also did this refactoring around the core services. We realized that the data processing should be separate from the data storage. This might also need to scale over time as the number of pipelines that connect to different data sources, they may have different security ratings. So by having the processing able to connect to the different accounts and different zones in the data lake independently was a key design decision around that. But there's more about the data lake later. And then, as we said, configuration-driven pipelines. So the main milestone for our project was deploying into UAT at the end of March. So this we'd set as our MVP, our minimum viable platform, our minimum viable product. And we wanted to make sure that we had that connectivity for end users. So we added to the platform a Power BI data gateway to facilitate connectivity between the data storage in Azure Synapse and the Power BI service or the SaaS platform. And once we did this, we had achieved that milestone of the MVP being delivered. We had the data into the UAT environment, which moved on to that next level of accessibility for end users. And we also had users with the ability to consume from Power BI. And this was a big milestone for the team, big milestone for Highways England. And our, like I said, our product owner, the head of data and engineering and architecture, went to social media and made a post on LinkedIn showing that we had end users with access to data for Highways England, which was brilliant. So so moving on from MVP, we were now looking at productionizing this service and making sure that we could move into an environment that handled live data. So one of the first things we need to do for this was the penetration test, and then actually the user acceptance testing. We needed to run through a number of different scenarios. So over the next 3 months, we're really busy hardening certain areas. So we applied a number of different blueprints that would specify the baseline that we needed for security. We did some performance tuning as well in the response to UAT. If we just go through this, and then we deployed to Azure Security Center so we could look at the recommendations and alerts, and we could apply some templates as a baseline. So the continuous compliance would then start to bring those in. We could look at implementing anything that we needed to make the platform more robust and to bring it to a particular level of compliance. We also moved into a hub and spoke network model for that, which was key for data egress protection. So making sure that everything within this platform that wanted to talk to the internet had to go through an Azure firewall meant that we could create rules that would block traffic to anything that we didn't trust. And it made sure that we knew everywhere that data was being sent as well. And then in July we had our penetration test, and we passed that at the first attempt. There were a few very informational things that we could look at, but most of the issues, everything was informational, and there was nothing that stopped us from them moving into a live environment at that point. So hub and spoke. We also looked at making sure the platform was right sized. We wanted to make sure that cost control was really adhered to. We had a particular budget that we wanted to keep within. So being able to make sure that the size of things like the data warehouse, the virtual machines when they were running and things was optimized was also key as well. So in August, we had a live service. We had we scaled out. We had additional data ingestion pipelines. We actually were working with a third party, a partner who were delivering a different data stream into this platform. And with that, we added CICD pipelines as well. And this was all secured by RBAC throughout the system, so that we could make sure that that users were accessing the right areas of the system, and that data was isolated correctly. So as we can see in the timeline at the bottom, starting at the end of December through to end of August, we had delivered a live data platform with a number of data sources in 8 months. So I spoke about the data lake design, and this is like a little more general, but the approach that we were taking for Highways England is to build out a number of different zones in here. So the key things in this design is that you have higher data fidelity on the left, so the data's in its rawest form, and then as you move towards the right, you're increasing the business value and its usability. So starting at the raw zone, you could have data in XML or JSON or CSV format. As we move into the conform zone, we start to apply data models to that to get to an operational data store, so that you've got hopefully a single view of entities. Alongside the platform, we were working on describing all of Highways England's data through an ontology, and this is where we started to apply physical models to the data, and then finally into the curated zone where we had the models that were going into the data warehouse as well. So as you see, with the value increases as we move from left to right, we had a secure zone as well, so that if data needed to be desensitized before it could enter the platform for analytics, so things like personal information, it could be removed in the secure zone, and policies would be applied to that, so that any data there has a very short time to live, and then that's built into the platform, so we don't have to worry as much. So it would be under the same security, but we know that the data retention on that zone is very, very short. So as data then moves through the different zones, it's been desensitized, and it can be held for longer. Above these different zones, we have a speed layer, which is to deal with streaming. So that allows us to almost accelerate the value through to the end user. So using Databricks, it's built on Apache Spark, and that supports micro-batch processing of data. So you've got near real-time functionality through that zone. And then as you see, there are arrows moving from top to bottom. So at any point in that speed layer, we can drop into one of the other zones and persist that data into its data store, or we can serve applications from the other end too. And all of this data falls into, there's derived information about that data. So things like how much data has been processed, how many columns are there, any data quality issues. That's what the metadata zone is for. We have a similar area in the data warehouse that shows how processing is being carried out. So we have single views of that data and the processing for diagnostics. And then we have to talk about sandbox area at the bottom, which is where the experimentation and exploration activities can happen for bringing data science to the platform. So I'm going to pause here a little bit, about halfway through, and just see if there are any questions that people would like to ask about that before we move on. Just give it a couple of minutes for people to type into Q&A. Brilliant. I'll continue then. So we spoke about automation and orchestration in the case study before. So what we'll do now is have a bit of a deeper dive into what that looks like, and then how we can actually deploy all of these different data services. So starting with like a DevOps pipeline, then the goal here is that you have your backlog of work that has a number of different work items, and the idea is to realize those work items and deliver the value to the end users through into the production environment. So there are various different steps we go through here of creating a branch in the source control repository for the particular work item that we're working on. At that point, all of the different artifacts are drawn together. So things like source code, infrastructure templates, testing, any dependencies, and everything like that. And that's committed back to the repository so that yeah, and a pull request is created to merge that back into the main trunk branch. The pull request is brilliant because it allows the team to really collaborate and to scrutinize each other's work. So you're getting quality built in by peer review at this stage. Once the pull request is accepted, then a build is triggered. So when the build executes, it will then run things like static code analysis, linting, unit tests, and to make sure that everything is correct and working as it should be. And the output from the build phase is an artifact. It's a compiled artifact which can then be deployed into release into the various different release environments. So during the release phase, that artifact will be moved through various different stages. So things like the dev environment, QA, UAT, production. I think the names almost don't matter. The fact that there are different environments is the key thing. And the difference between the environments is really controlled by configuration. So things like how do you connect to that environment? Where does it store its data, the names of services, and things like that would all be configuration. And the assets being deployed by the artifact should all be parameterized so that they can work across these different environments. Once deployments happen, that's when we can start to run integration tests and acceptance tests on that, and also performance testing, security testing, infrastructure testing. It can all be built in here. And what you get after any one deployment is a set of test results published for that artifact. So you can increase in confidence as you move through the different stages and environments. You can also put approval gates between those environments so that you have some control of what moves into production. There's probably a nirvana where most people commit code, it's reviewed, it goes to live. But that's great for the Netflix, Ubers, Spotify's. But there are a lot of organizations that want a bit of control over that. They want the change windows, they want to have approvals, and all of these things can be linked into the process to automate as much as can be. So a lot of the key principles for DevOps are automating the delivery of value that we spoke about earlier. So this is a process that deploys, which is great at deploying infrastructure, deploying pipelines, deploying web applications and things like that. But what we're going to talk about for the next part of this session is data services. So things like data science and machine learning models, and how this process is refined to support those. So if we just move on to the next slide, we have a slightly revised diagram. So we still have a backlog, we still have a repository, and we still have pipelines publishing the work. But one of the main things in data science is you often need access to real data. It's not easy to work with generated or manufactured data that you could use for testing transformations and things in data ingestion pipelines. So that often means that you're in a production environment from the beginning, and you need to have like different stages that you move models through on their journey to being consumed by a live service. So here we've kind of replaced those environments with Databricks here, and specifically the MLflow model registry, which does support development, staging, and production phases for a model. And you can tie your analytics to pull a particular like phase of a model into pipelines. So that gives you that concept of dev test and production, but you are connected to the live data. So we have two different teams here. One of them, using notebooks, is really focused on data exploration, testing value, and delivering proof of values to make sure that that a particular business case is going to return the right sort of outcome for the business. And they work through the same kind of process here of collaborating, of working with a source controlled repository, committing and deploying that code, and then executing it. The notebooks will often run interactively and give feedback straight away, but they're really informing like the second team. It probably should be phase one, phase two, but it could be handed over to an ML engineering team too. For that main development in a tool like PyCharm using Python or some VS Code works equally well. And at this point, we're really coding up libraries, robust libraries that go through the different stages of model development. So things like extracting features from the data and which have been defined by the notebook, understanding the lifecycle of those features, and making sure we've got tests and data quality validation and things like that, which are all built into the library and into the pipelines, so the data pipelines, CICD pipelines as well. We also have model training and model serving pipelines that need to be created as well. And all of these form an artifact that can then be deployed. They may be one artifact, they may be independent artifacts for different versioning, but the process of deploying and consuming is very similar. So when the model training executes, that's going to run through all of the code that builds the model. Let's move on. So we look here that this is what we just spoke about. That we use the right tooling. We want to meet the teams where they are with the tooling that they're using. We want to set up guardrails. We want to set up like process that they can work with that's automated, so it's not intrusive. That it is really aimed at accelerating their development processes and making sure that they're not wasting time. So this is the fail fast approach here. And then as we move through, like I said, we have the artifacts that we've built, and it can be many different artifacts for the different stages of the pipeline, or it can be like a single artifact. And we would deploy that into our data environment. So in this case, it's Databricks, but we could be using things like Azure ML Service instead, or equally any other cloud provider. So things like AWS SageMaker or other alternatives. And again, we're using that configuration to control how we access those environments and the user accounts that access the platform. As the model executes in that pipeline and it's trained, we have a number of different metrics that we want to record. So everything around reproducibility, so understanding the versions of data that have been used for different data sources, so that we can go back and create this exact same model again if we ever needed to. We also track the metrics that come out. So when you evaluate the model that you've created, to make sure that it's generalizing appropriately, that it's not overfitted, that it's accurate, then all of those metrics would be recorded for the model as well in MLflow. And that really helps when it comes on to like the operationalizing, sorry, the model. So if we move on. So MLflow provides that standardization of format, and that really helps us to consume the model in different applications. So you could have batch processing where all data is loaded in Databricks and it's going through different transformations, in which case the model can be applied. You can have streaming use cases where data is being processed in a continuous stream, or even a real-time API where a user is interacting with your website directly. And you need to be able to serve them a response almost immediately. So there'll be a number of different stages to move through. So the feature extraction, the scoring of the data with the model, and then surfacing the results back to the application. And MLflow can provide some like its own guardrails here. So there's an API where we can query how the model was trained and what the characteristics were of that particular model. So we can then start to examine both the data that we're passing into the model when we want to extract predictions, but also the scores which we are going to serve to the end user. And this is where we can actually check to make sure that there hasn't been model or data drift occurring. So all of these are tracked and monitored, and we have performance for that model that is tracked over time, and we can use cloud native logging services to surface this information to users. We can hook into services like Azure Monitor for notifying users if there are problems with that data, or implementing a webhook if we need to go back and retrain a model or re-engineer features and things like that. And again, it comes back to how automated you want the process to be and how mature the team is that is building and deploying models, as to whether it's seamless retraining, or if you want to actually have those stage gates, promotion, and levels of testing, like manual testing applied as well. So we keep moving through. So the other benefit of the pipeline is you have the end-to-end lineage. You can see how the model has been over time, and you can recreate the model if you need to. So if there's any regulatory obligation, you can get back to that. So yeah, here is is what a model delivery pipeline could look like. And then we move on to model hosting, which we touched on briefly before, where you have things like batch processes where models are consumed by like Databricks or Azure Synapse. They can be in streaming or batch applications, or also models can be hosted as APIs through Kubernetes and made available to users. And we start to see the like all of the cloud native services fitting in here, like API management, Event Hub, and data lakes. And you can see how that fits back into the data platform that we spoke about at the beginning. So not only are we onboarding data, modeling data and being able to serve it through data warehouses and dimensional models, but we also we can layer data science on top of that and have advanced analytics that we can serve directly to end users. And then we're going to look at logging and monitoring as well. So logging and monitoring in Azure for these types of activities really fit into two different applications. So you've got application insights, which is really looking at your trace level logging. So how is an application running right now? What sort of things is it doing? Where was it in its flow when it's executed, when it failed, if you get errors and things, which is great for developers and data scientists and data engineers if we need to go back and look into problems with pipelines and models. And then there's log analytics, which captures the service level events, the metrics, the diagnostics. And both of these services are built on top of Azure Data Explorer, which provides a really powerful engine for indexing data. You can quickly like zoom into where a problem is. So here we have a query that is looking at the 7-day usage of a data warehouse. That's actually the visualization at the top. It shows different days and it shows the different level of performance and how much of that performance is being used. So this was from a development environment, so it's relatively low. But I mean, the same principle applies. You can build visualizations from this that can show the operation of things over time, and that fits into services like Azure Monitor, where if the queries start returning errors, or you can have a query that identifies errors, and if it starts returning results, that can then feed into a particular action group within Azure for serving emails, SMS messages, voice notifications, or even hooking into webhooks and functions. Or you can just visualize the data in Power BI as well. There are applications for that. Some of the other really interesting features of Azure Data Explorer are things like built-in AI features around anomaly detection, things like geospatial data. So if you wanted to analyze logs and see where things are happening, you can do that. And it's not just limited to logging either. Azure Data Explorer is its own like first-class service in Azure, and that you can build applications on top of, and it supports like real-time streaming in cooperation with services like Databricks and also bringing in machine learning models that you can actually score as data is being ingested as well. But yeah, so we often use this in its logging application and incorporation into applications this way for that alerting, monitoring, and that really rich feedback. So as we start to wrap up now, so we spoke about the benefits of DataOps is really around delivering value, around reproducibility, collaboration, evangelizing the cross-team communication. And this is one of the real key points, is data scientists need to work with the business to understand the problem domain, to understand the data, to understand the application of that data by the end users. And making sure that you've got subject matter experts and working in teams is one of the key things around DataOps, MLOps as well. And then also planning for production. So we've shown a case study with the steel thread approach where we start with something really, really simple. We prove that it can be done, that it's going to work, and then we look at how we're going to scale that. But we design in the production level features from the beginning around security, compliance, and governance. And then there's always the focus on making sure we deliver value to the end user. And then finally, when we work with clients for this, we're looking at making sure we have like an enduring capability left behind from the projects that we work on. And we do that with like co-located multidisciplinary teams with inclusive ceremonies. So we work as one team, and it doesn't matter whether it's a single client that we're working for, whether it's whether we're part of a blended team with their own employees, or if it's working with a delivery partner as well. And all of this is about that one team ethos and making sure that we have that common goal around delivering the value to the end users. And I'm going to finish off with the slide about a white paper that we've produced that covers quite a lot of successfully delivering data through DataOps and the topics that we've spoken about today as well. And onto questions.
Thanks for that, Simon. So if anybody has got any questions, you can still submit through the Q&A functionality. I probably should add a bit of a shameless plug as well that we are hiring across the board, not just in Birmingham, all of our offices. So I will send some details after the session on how you do get in touch if you are interested. So nothing's come in at the moment, Simon. So is there anything else you want to cover before we finish off?
No, I think we have got one there. So how important is establishing the enduring capability or culture to realise the value of such a platform? So I think realising the ongoing value of a platform, I think it is really important that we do build that culture, that we can enable teams to like operate the platform. So a lot of so once the platform's been built, you'll have a number of tests in there. You'll have code that's being deployed, and you'll have those guardrails in place for making change. And that's one of the things that DataOps really embraces, is being able to make change at speed, but safely. You've got the quality things in place. So if you've built the culture around working in that way, that you're maybe doing test-driven ways of developing code, that you look at how are you going to test what you're delivering first, you enhance those guardrails, then you can make changes to the application code, and you can automate it through the pipelines. I think also the collaborative nature is really important as well, making sure that you're always working with stakeholders, particularly enterprise architecture and information security, to make sure that your changes fit in with their vision as well.
Brilliant. Thank you so much for that, Simon. Well, I hope everybody enjoyed the session. We will be following up with the recording, and if there's any questions that you think of that you wanted to get through to Simon, that's not a problem. Enjoy the rest of Birmingham Tech Week, and we hope to see you soon.
Right, thank you.
Thanks very much. Take care. Bye.